Okay, here we go. Um, this is a review sheet. Well, it's a very tiny review sheet. I'll give you another one on Wednesday. But this gets you practicing. So, first question. Liz wants to buy one bag of chips and several bottles of soda that cost $2 each. Write an expression to express the total cost C. Use the table below to show her total if she buys 3, 4, 5, 6, and 7 bottles of soda. Alright, so let me get this. I like the statement. Okay, you have to come up with an equation. Have to. No choice here. So if we want to find, and here the total, we're going to write total cost. How would we calculate the total cost of what she spends here? Okay. And the total cost would be $4 for the chips. No matter what, she's buying a bag of chips and soda. And each bottle of soda is $2. And we're going to multiply that 2 times S. Okay, that's the letter S. She buys one bottle of soda, is 2 times 1, $2 for the soda, plus a bag of chips, 6. She buys 2 bottles of soda, it would be 2 times 2, 4, plus a bag of chips, 8. So that's our equation. So our equation is going to be C equals 4 plus 2S. Okay? My independent variable, okay, the cost is not the cost, it's either the cost or the soda. So the cost depends on the sodas. Okay, so my independent is the soda. My dependent is the cost. So little chart here. On the chart, on the left side, we usually put our independent. We'll write sodas. And the cost, the dependent, goes over here. We want to know how much it would be if she bought 3, 4, 5, 6, 7 sodas. So if it's 3, 3 times 2 is 6, plus 4 is 10. If it's 4, 4 times 2 is 8, plus 4 is 12. If it's 5 bottles of sodas, it would be 14. 6 bottles of soda, 6 times 2 is 12, plus 4, 16. And then 7 bottles of soda, 7 times 2. 7 times 2 is 14, 18. Okay, now we got to set up our equation. Now, you're going to extend this line, okay, going up and then going up like that. You got to decide where your independent goes. Your independent will go here. This will be our sodas. And your dependent always goes up and down here. Okay. Now, I saw a lot of people, or the ones I kind of saw today, they they number their bottom here, going left to right, like this. 0. And because they didn't see 1 and 2 here, we didn't ask for how much you would pay for 1 and 2, so they automatically went like this. 3, 4, 5, 6, 7. That's a problem, because the intervals between numbers are not equal. You can't start skipping by 3, which is from here to here. That's 3, and then all of a sudden you're skipping by 1s. Your intervals have to be the same. Okay, so even though we're not using 1, 2, 3, you still need to put them. It's part of your scale here. It's part of your number line. 1, 2, 3, 4, 5, 6, 7. Okay, so don't start at 3, but if you did start at 3, make sure the next number is 6, because you're skipping or counting by 3s. That's okay. But if you start by 3 and then you start counting by 1s, it's not going to work. And up and down, I guess, you can use 2, 4, 6, 8, 10, 12, 14, 16, 18. Alright, so she has 3 balls, 3 sodas. She would pay $10, which is about, it's right here. She has 4, she's paid 12. She has 5, she's going to pay 14. She has 6, 16, and 7, she'll pay 18. Now, if you connect the dot here, okay, start right here, and you connect it. Okay, this one is not going to touch 0, but instead it touches right here at the 4. What does that mean? Well, if she buys 0 bottle sodas, how much she ends up paying? She ends up paying $4 because she's still buying the bag of chips. Okay, it doesn't mean that just because she didn't buy any soda doesn't mean she's paying nothing. No, she's still paying $4 for the bags of chips, and that's what this graph tells us. Okay, at 0 bottles of soda, she pays $4, which is the bag of chips. Okay, am I going back? Am I going forward? Okay, and I guess I'm doing this backwards, so this is the problem that's on top of the sheet, not at the bottom. Corey runs 3 miles every day. Write an equation to express the relationship between miles, M, and the days. Okay, use a table below to show how many miles he runs. We want to find out. It says here in the question how many miles he runs. So that tells you what we're looking for. We're at the sentence here. We want to fill that sentence up. We're going to find the total miles because that's what we want, not the total days. To find out how many miles he's run, you're going to take what? 3, and you're going to multiply by the number of days. Okay? It says 3 miles every day, so in 1 day he runs 3 miles. In 2 days, he would multiply that by 3, which is 6. In 3 days, he multiply by 3 again, which is 9. In 5 days, he multiply by 3 again, which is 15. So forth, so forth. So we can write an equation from that sentence, which is M for miles equals 3D. Your independent is your days, or just D, and your dependent is miles. The number of miles depends on the number of days. Okay, on the table, you want to write your independent here, your days, and your total miles over here. And we want 1, 3, 4, 8, 10. So if he runs for 1 day, it's 3 miles. 3 days would be 9. 4 would be 12. 8 would be 24. And 10 would be 30 miles. Okay, let's go to our graph. Let's extend our line here. Okay. So your dependent usually goes on the side here. This is your miles, the total miles that he runs, which depends on the number of days. Okay, that's 0. So the number of days, we go from 1 to 10. So let's start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And notice on the other side is 3, 9, 12. So why don't we count by 3s? 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. All right, so let's try this. 1 day would be 3 miles. We need 3. 3 days would be 9 miles. In 4 days, he runs 12 miles. In 8 days, where's 8? He's running 24 miles. And 10 days, he runs 30 miles. Let me turn the water off. Pause. All right, now you can connect the dots. And we're going to use this function I have. And if you connect them, you'll notice this time, this one, you can go all the way to 0. Well, and you can make sense out of that. Because let's say, if you go to 0 over here, if he runs 0 days, how many miles is he going to run? 0. Okay, and that makes complete sense. If it doesn't run, there are no miles. So that makes complete sense. As whereas the problem before this, okay, it didn't hit 0. It hit a number on the y-axis. Okay. We did that. Okay, use fact families. Okay, 2 different ways of doing it, and I'll do it both ways. Okay, so 602, ignore this. Okay, the other 2 classes, pay attention. First thing you want to do is set up your triangle. So this is going to be a plus, it's going to be a minus and a minus. I'll make that a plus, not a multiplication sign. Okay. Alright, so M goes over here on top, 3/5 goes over here, and 1/4 goes over here. You can create your families here. So another family you can say is M minus 3/5 equals 1/4. You can also say M minus 1/4 equals 3/5. You can also say 3/5 plus 1/4 equals m. Or you can say 1/4 plus 3/5 equals m. So we can either use this one or this one to help us find the value of m. Alright, let's do that on the side. So we get 3/5 plus 1/4 equals m, and the LCM is 20. This would be a 12, this would be a 6, equals m. And our m, the value of our m is 18/20. Okay? Let's do a check to make sure our answer makes sense. So our check, we copied the original equation, which was m minus 3/5 equals 1/4. Let's see if that's indeed true. So m, we just found out, was 18/20 minus 3/5 equals 1/4. So to subtract those, we actually find the LCM again. The LCM is 20. This one's already at 20. So 5 here times 4, you get 12, equals 1/4. So 18 minus 12 is 6. Over 20, and that's something's not right. Times 4. I'm gonna press pause. Alright, I found my mistake. My mistake is over here. It's not 6/20. Okay. So I erase all this here. So it's going to be actually, LCM is 20, and it's times 5 at the bottom, so times 5 at the top, which makes it 17/20. That's the value of our m. Alright, so let's substitute. So 17/20. And 20 is our common denominator, so this stays at 17. And you get 5/20 equals 1/4. And 5/20 is indeed 1/4 if you simplify it. Okay, so our m is 17/20. This one's a multiplication one, so it's times, divide, divide. And 3.4 times y equals 19.04, so 3.4 times y, I'm going to put y on that corner, equals 19.04. Okay, so another thing you can say is that y times 3.4 equals 1904. You can use division now, and we can say 19.04 divided by 3.4 equals y. And we can stop here because this is the one we want to use. Okay, so if you divide 19.04 times 3.4, I have no clue what that's going to be. And hang on a second. And if you divide that out, you actually get that y equals 5.6. Okay, you need to do your check. So in your check, your original equation said 3.4, the decimal, times y equals 19.04. Let's see if that's true. So you're going to multiply 3.4 times 5.6 to see if that's 19.04. Okay, take a couple of seconds, multiply these two out, see if it's 19.04. And if it is, it does match the value on the other side. Okay, there's that. And then, okay, O2, you have a different way of doing things. Okay, so O2, we're going to draw that line in the middle. Okay, and this is a subtraction equation, and you want to do the inverse of subtraction, which is addition. So you're going to add 3/5. Okay, I'm going to add 3/5 on the other side. These two cancel out, and you get m equals 1/4 plus 3/5. And 1/4 plus 3/5, you can't add them as it is, so you got to find the LCM, and that's 20. That's 20 times 5, and then times 4 here, which is 12, and you get 17/20. Okay? And then you substitute, you still got to do the check. m minus 3/5 equals 1/4. You just found that 17 over 20 was m, minus 3/5 equals 1/4. Alright, so, and if you actually do the calculations here, okay, you get 20 minus 20, and that's 412, and that's 17. So 17 minus 12 gives you 5 over 20, which equals 1/4. Is that true? Yes, it is, because 5 over 20 simplified, it is 1/4. On the other side, it's a multiplication equation. The inverse of multiplication is division, and I'm going to divide both sides by the coefficient, which is 3.4, and this is 3.4, and y equals 5.6. These two cancel out. You get y left over. You isolated your variable. Okay, and you find the values. 19.04 divided by 3.4 is 5.6. Go back to your check, which is 3.4, and multiply by y, which in this case is 5.6, to see if it's 19.04. And if you actually multiply it out, you will see that that does equal 1904, which is 1904 on the other side. Okay, that was for 602. Bottom, combine like terms. Ooh, okay. So you want to combine the terms that are okay, the same. Well, here's you have 8m. Is there anything that has an m? And m only. This one is m, but it's m to the third power, which makes it completely a different species. Can't combine those two. Well, the 14 and 9. Yes, you can. So you can't throw the ones, you can't throw 8m out. It's still part of your solution. So you're going to write 8m. These two you combine together. 14 minus 9 is 5. And also the m cubed is part of your solution. You don't do anything to it, so it's still part of your expression. Here, 5y minus 8. You can't subtract something that has a y with something that doesn't have any y's, but there's a y, something that has a y in the back. So those two you can combine. If you were to combine, you would get 5y minus 2y. 5 minus 2 is simply 3. Y, and then you copy this one, okay, which didn't do anything, but it's still part of your solution. You get minus 8. Okay. Let's see. Use a commutative, associative, or distributive property to find the equivalent expression. Name the property used. Well, here. What's one thing? Can we change this to an equivalent expression? And here we can write A plus B plus C, and we're going to put parentheses here. We're going to group it differently. In this, on the left side, A and B are added together first, and on the right side, B and C are added together first. And the name of the property is associative. Here, let's write an equivalent expression. Another way of expressing this, you can use the distributive property, which would be 5 times n minus, and then 5 times 8. And this is just simply 5m minus, and 5 times 8 is 40. So that is the same thing as this. Okay, they're exactly the same. 7 plus m, you can switch it around, and you can make it m plus 7. What's the property that you just used? Is the commutative property of addition. Okay, kw, k times w. Another way of saying that is simply w times k. And again, this is the commutative property, but of multiplication. Okay? Substitute to find the value of the expression. The equation C equals 5 over 9, parentheses, F minus 32 is used to calculate the equivalent temperature in Fahrenheit from Celsius. Okay, little background. I think probably the United States is the only country I know of that uses Fahrenheit, okay, to measure temperature. The rest of the world uses Celsius. Okay, so if you say 50 degrees Fahrenheit to somebody who has never lived in the United States, they have no idea how cold or how hot it is. Okay? So, just to give you an idea, freezing temperature in Celsius is 0, in Fahrenheit is 32. Okay? So, there's a big difference there. Alright? So, what was it? This is basically substitute. Here's your expression. I'll write it. Celsius. This 5 over 9 F minus 32. So if it's 50 degrees Fahrenheit, how do we change that to Celsius? Well, you use this equation right here. What you're going to do is take the 50 and tell that Fahrenheit, you have a temperature of 50 Fahrenheit, so you're going to switch it right here in the F. So you're going to write C equals 5 over 9. And in parentheses, instead of the F, you can write 50, because that's the values given to you, minus 32. Order of operations, you get C equals, what are you going to do, 50 minus 32, or are you going to do 5 over 9 times 50? You're going to do 50 minus 32, so you copy the fraction for now, 5 over 9, and in parentheses you have 50 minus 32, which is 18. Now it just becomes a fraction times a whole number. Well, you can put that over 1, okay, and you multiply fraction, top was top, bottom was bottom, 5 times 18, that's 40, it goes 4, 90. 9 times 1 is 9, or 90 over 9 is simply 10. So, if it's 50 degrees Fahrenheit in the United States, that is equivalent to 10 degrees Celsius. Okay. This one is working. It's find a common factor in each term to rewrite each expression. Remember, we're taking the distributive property and sort of working backwards, if you want to think of it that way. You're factoring it out. So here's what you can write. So think of a number that goes into 28 and 36. There are quite a few. I would pick, I don't know, you can pick 4. Does 4 go? Yeah, 4 does. So 4 goes into 28 and 4 goes into 36. 4 goes into 28 7 times. 7y, and 4 goes into 36 9 times. You can always double check by actually doing the distributive property. 4 times 7y is 28y, good. And 4 times 9 is 36, good. So that works. So this expression, 4 times 7y plus 9, is the same thing as saying 28 plus 36. On the other side, same thing. Okay, if this helps setting things up for you, you can. I think it does for me. And we have, again, to think of a number that goes into 8 and 24, you're finding a factor, a common factor between the two. It doesn't have to be the greatest common factor, just a factor. Several choices here. Let's pick 2. 2 goes into 8, 2 goes into 24. So let's take that outside. 2 goes into 8 4 times. And 2 goes into 24 12 times. Don't forget to write the variable. I'll actually do another one. So we can do 4 as well. Because 4 goes. So if we use 4, 4 goes into 8 2 times. 4 goes into 12 6 times. Let's see, do we have other options? Yes, we can use 8 too. 8 goes into 8 and 8 goes into 24. So 8 goes into 8 1 time, or 1/8. And 8 goes into 24 3 times, or 3n. Let me go back here on the other side. There was 4 we could have used to, not 7, that's it. Oh, we can have used 2. So if 2 is a number outside, 2 goes into 28 14 times. 2 goes into 36 18 times. Is there anything else? 2, 3, no, 4, we did 5, 6, 7. That's about 14, no. So that's it. Okay.